Hey everyone, what's up? So I'm going to do a quick video today about something that's a little bit more than Hello World. I did this on a webinar with Jfrog, but it was a little bit more intense. So I thought we would scale it back and start from the basics. And then in a future video, I'll have kind of ramping things up a little bit more. But to get started, I thought it'd be cool to do something other than Hello World. So I have a Java chat application here, just a public project that I forked from Calicoder. And I thought it'd be cool to see if I could get it cloud native ready out onto a Kubernetes cluster using Draft, Helm, and Azure pipelines. So let's see if we can do it. I'm going to start out here on GitHub, and without leaving GitHub, I'm actually going to go to the marketplace. I'm going to open a new tab. And the marketplace on GitHub has a collection of tools that will help you improve your workflow some way, one way or another. They have a wide variety of different categories. I'm going to select continuous integration. And if I scroll down, I see that Azure Pipelines actually already has a continuous integration tool right on the GitHub marketplace. So I'm going to select that. And the cool thing is number one, it's free to get started. You can go ahead and set it up and add it to your account. If you have open source projects and you're using a public repo, Azure Pipelines will give you free unlimited build minutes for Linux, Mac, and Windows, and you could do multiple builds as part of one CI. They'll even give you 10 free parallel jobs for your public repositories. If you have private repos, they give you 1,800 build minutes and still one parallel job. So I already have it installed to my account, but I do want to configure access for it because it actually has to have read-write access to my GitHub essentially account because it's going to have to make changes to repos that I authorize, but I'm not going to want to give it unsolicited access. So you can see right here, I'm in settings, I'm under applications. I'm going to go over and hit configure, and I've already authenticated and signed in, but you might be asked to enter your GitHub password. Scroll down and I can see that I'm going to give it permissions to write code, read metadata, and even do things with checks, commit statuses, deployments, issues, and pull requests. Right now, I only have 2 repositories, and neither of them are the Springboot application that I want to work with. So I'm going to go ahead and select that application, and then I'll hit save. Once I hit save, GitHub is actually going to do the handoff over to Azure Pipelines. I'm already signed into my Microsoft account, so there's already authentication understood. However, even if I didn't have an Azure Pipelines or Azure DevOps account, I can still get started because I'm taken right to a sign-up page. So I can select an existing organization, or I can choose to create a new one. An organization is where you keep your projects and your builds. I can choose to select an existing project. So rather than starting completely from scratch, because I already have several accounts, I'm just going to use my demo account. And then I've already created a project for this. So I'm going to choose Jfrog because this is a project I did for their webinar. And I'm going to go ahead and hit continue. Now, this is going to take me and log me into my Azure DevOps organization. I'm going to have to select the repository where my code lives for this project. So I see right here, it already detects the 3 projects that I gave access to. So I'm going to go ahead and choose Springboot. It's going to make sure it has the right repository permissions. And now it's going to ask me if I want to configure the pipeline. Based on the code that exists in my GitHub, it knows that it's already a Java project, and I'm probably going to want to do something with Maven. But if I didn't, I could choose just a minimal pipeline, which is just a minimal YAML file, or I can use an existing YAML if I have it in a different branch of the repository. In the event that I didn't want to do something with Maven or Starter and I actually wanted to build a different type of pipeline, there are other templates that are predefined. But for today, I am going to select Maven, and it's going to give me, again, just a simple starter project. It's going to trigger on the master branch. It's going to give me a Linux hosted machine. This is the hosted machine that Azure Pipelines gives me to actually run the builds. And then it's going to run a series of tasks. In this case, it's only running one task, which is just Maven. With a POM XML, I specify my Java version, test result file location. Everything is very basic. And honestly, the first build probably won't work because this isn't really doing anything that I'm going to need for my desires of cloud native or really as a Java application. But let's go ahead and save it because it'll give us a launch pad. So I'm going to hit save and run. And that's going to automatically ask if I want to commit an azure-pipelines.yaml to my repository. So I can commit directly to the master branch, or I can create a new branch and start a pull request. I'm going to do master branch for the purpose of today, and I'm going to hit save and run. Once I do, this is going to go off, commit and push over to GitHub, but it's also going to fire off a build simultaneously within Azure DevOps. So you can see it's configuring right now. It's going to get ready to start the build, and I can see that it's starting. If I go over to GitHub and we'll just hit refresh here, I can see that the Azure Pipelines YAML was added 20 seconds ago, and we can see that the build is starting in the background. So I'm going to go over to Visual Studio Code. I have the same GitHub repo up and running here. I'm going to pull any changes, and it should pull down that Azure Pipelines YAML. So like I said, I'm going to want to change it, and I know I'm going to need to add tasks for Docker and Helm and Kubernetes, but I need those files. So one thing I did in advance is I'm going to go over to Google Chrome here, and I have a build pipeline that's a visual continuous integration that I've already created with tasks that make sense for this kind of project. So I'm just going to edit it so you can see. And right off the bat, you could see that the agent pool still is a Linux agent pool. You can see that I'm getting sources from GitHub, just as I am in a YAML file. And then we have what's called an agent job. I can set up different jobs in my pipeline. I can set up a Windows job, a Linux job, a Mac job, whatever I need to build. But since I'm going to actually want to take this Maven application, this Java application, bundle it up into a Docker container, and then deploy it using Helm on a Kubernetes cluster, I chose tasks that made sense for that. You can do that using what's called the task edition and the task runner. So you have all these different tasks here that are just built into Azure DevOps. If there's a task that you want that you can't find, it may exist in the marketplace. We have a variety of different third-party tasks, including from other clouds, for example, AWS, which is actually written and maintained by AWS. And in the event that that doesn't work, you can actually do, let me go ahead and show you here. If you wanted to do your own command line, you can run a bash script or a PowerShell script. You can pretty much make Azure DevOps do anything that you want it to do. But for today, I already have these tasks defined. I already set up a Docker registry connection to Artifactory, which is my Artifactory instance over here. If I log in, you can see I have a ton of different artifacts. So I already set up that connection. But I want to keep this pipeline in YAML. I don't want it to be Visual CI. There are benefits for having your pipeline right alongside your code. That way you can version it as well as with your packages. And on top of that, you can keep your YAMLs per branch, right? So all I have to do after I've built this task runner out is actually click on the agent job, view the YAML, and it'll pop up in a little window here, and I can just copy that over. Once I've copied it, I can go back over to Visual Studio Code. We can go ahead and copy this. Well, not copy it, but you know what I mean. We'll paste it in, delete the other, paste in the new. So you can see the pool is still Ubuntu, and it's just defining the same tasks you visually saw. I have build an image for Docker. I have push an image. I have set up my build server because it's a hosted one. It's not one that I maintain with Helm. And then I'm going to use Helm package to package up my Helm charts. And I'm going to copy files and ultimately produce artifacts. Only this pipeline still won't work because I don't have a Dockerfile. I don't have Helm charts. So this is where draft comes in. So let me go ahead and make sure I'm on the right. I'm going to do my bad Wi-Fi, which if you've never seen my demos live, that's my alias for switching to a local Kubernetes cluster. This is my Docker for desktop. It's running on literally Docker on my desktop. Kubernetes is part of Docker. And so you can see I have it enabled. And right now, let's do a quick Helm ls. I shouldn't have anything, and I don't. If I do kubectl get pods, nothing's running. So the first thing I'm going to do after I've made sure that I'm using the right Kubernetes cluster is I'm also going to use Draft. Draft is a tool that enables hacking for developers. It streamlines it. So I can actually get up and running with Helm charts, with a Kubernetes deployment, with 2 commands, because Draft is going to auto detect the language that my application is written in. So the first command I'm going to do is draft create, and that's going to detect my language and give me files that I'm going to need to get started with this deployment. So you can see right here, it detected Java right off the bat, and look at all the files that it added. One of the big files is this Dockerfile right here, and you could see it's actually using what's called a multi-stage build. It's giving me a base image of Maven. It's running my Maven command, so it's actually going to package up the Maven dependencies inside of my Dockerfile. And then in a second stage, or the second part of my Dockerfile, it's going to copy the contents from that, my jar, from the first step, from build. This is labeled as build. It's going to copy it and make it accessible in the second step. This is considered a best practice in general because you're making smaller images. Often what you need at build is not what you need at run. So I would recommend this in general. And it's cool that, again, Draft does this for me. But it's not perfect. There are a few things we're going to need to change. For one, I need to update the port because my application serves on port 8080. So I have to change that in 2 places. And then I'm also going to remove this with dependencies because the jar file that's produced from this just has a .jar. And obviously I have the wildcard. Now I have to change the Helm charts as well because this is only the Dockerfile part. This doesn't have anything to do with my deployment. So Draft created my Dockerfile, but it also created my collection of charts, which is my Helm package essentially. And I can see I have my values, which is my knobs and dials. It's just a very simple application, very simple service. I could change this to Java chat. It's not important, doesn't affect the way it runs, but I am going to change the port again here to 8080. And I'm going to change my CPU and my memory because this is a little bit more robust of an application. So even though best practice is setting resource requests and limits, it is just giving me the bare minimum. So I'm going to choose 512 for the request and the limits. And let's go ahead and increase the CPU to 256. All right. So now that that's done, we have the ports working, we have the Dockerfile working. I could try to build this locally and it'll take a little bit of time because it's going to have to do the clean package commands and all that. But you'll notice it'll actually break because this base image has a compatibility issue with one of the tests that exist in this particular project. Under test, there's a failure. So let's go ahead and actually run draft up and watch that command fail and then watch how we'll fix it. Okay, so you can see right there, it failed just as we knew it would. I can copy the draft logs. This is one of the cool things about draft. Paste that in and we can see the output of the failure. So if we scroll up just a little, you'll see it failed to execute the Surefire plugin. So there is a known issue with that particular base image. So right now, a workaround around that is we are going to change this to Alpine. So it's just a different version. I'll save and I'm going to do the same command again, draft up, and it's just going to try to re-release and build. And this should succeed and it'll actually release into my local Kubernetes environment running on my Docker cluster. It'll actually be a full-fledged application. While that is building, you'll see that actually it failed as well on my Azure Pipelines build for a similar reason. So one of the benefits of using, again, Docker is I can contain my environment, right? It's a whole encapsulated runtime, which makes it immutable and portable. And Draft gives you the scaffolding and the framework that you can then adjust as needed for your environment, whatever makes sense for your application. So I'll click on this. You can see, of course, Maven failed. Take a look, and the logs are going to be quite huge. Thank you, Maven. So we'll scroll all the way down. Whee! It's like a roller coaster at Disneyland. And look at that, we got the same Surefire plugin. So this is a known Maven issue, and we just have to combat it in Docker. Docker, like as we know, makes it really easy to kind of keep our dependencies encapsulated. And to be honest, I like using Alpine-based images in the first place, though in the next video, I'm going to show you how you can create your own and maintain your own. But Alpine images are typically significantly smaller of a footprint than Debian-based images. So we'll go back over to Visual Studio Code. We'll watch this finish building and releasing into our environment. And then we'll do the next step, which the next step is going to be actually making it cloud native ready. The first part of development is always going to be doing everything locally, making sure our local environment workspace, unit tests, everything is done before we check in. Once we have that done, we can actually get it deployed out cloud native and try to deliver value, because obviously that's our end goal as DevOps practitioners, is to continuously deliver value. So I'll circle back once this finishes building and releasing. There we go. And so now that we updated that base image for our build, we can see that it was successfully able to complete. So one thing that I want to try just to show you is we'll do kubectl get pods. And you can see the application is up and running. I could do the same thing with kubectl get services. I'll hit enter. You can see the service is also up and running. This is running for 20 seconds, 28 seconds. I can do a Helm ls. I can see the Helm deployment was deployed, the time matches. I have it on military time, but it's 3:45 p.m., 3:45 p.m. So all that looks good, but the application is still actually booting. And so this is another thing I like, is if I do draft connect, which will actually create a proxy over to port 80 on my running container, I'll be able to see the logs as it starts launching, right? So you can see right here, it's initializing everything. It's not quite ready for me to go look at the application. Mapping URL paths, adding welcome page. This is one of those reasons that you needed to increase the memory and the CPU. When I didn't, and I left it at the basics, this took like 10 minutes for it to start. So I'm going to scroll up just a little. There's a line from draft that I'm going to want. So it says right here, connect to Spring Boot WebSocket application on localhost. So like I said, this is a proxy. So I'm just going to grab this, scroll down. And if I go over to Google Chrome, we'll open a new tab, I'll hit enter, and I should see my chat application, which I do. So that's a good sign. It means that it built locally, it released into a local Kubernetes cluster. So the next step is making it cloud native. I have done this part of the demo at conferences like Build and Ignite. So let's go back over to Visual Studio Code. And one of the things that I do is I show how you can streamline your Helm charts for that cloud native access, which essentially means I'm not going to just publicly release this application to a public repo. I'm usually going to store it in a private repo. So I have to make sure that my Helm deployment knows I intend to push it to a private repository. So we go over here to my values file. The first thing I'm going to do is add what we call image pull secrets. Now, if I'm using Azure Container Registry, I can get a little more creative with service principals. But if I'm not, the previous way that everyone was considered a standard was, again, image pull secrets and just making sure that's part of your declarative syntax. So to do that, I am going to add in image pull secrets. I've already created that secret, kubectl create secret, in the Jfrog namespace that I'm going to deploy out onto my Kubernetes cluster on Azure. And I'm also going to enable ingress. And again, I walked through ingresses in my previous video. So you can see that this application at the end of it should be available at jfrog19 and then k8az.jessicadean.com. I also have annotations for an Nginx proxy, because that's my preferred proxy, a cluster issuer, and I'm going to make sure, of course, it's SSL encrypted, so TLS is enabled. But the values file is just the values file. This is going to reference our templates. So I need to make sure what I just added also exists in our templates. So since Draft created our templates, we can go over and modify it. So I'll go to my deployment YAML first. And there's two different parts of spec, but the spec I care about is how I'm going to specify my containers get created. This is where I'm referencing image and image repository. So right above this section, I am going to add in an if values image pull secrets exists, append and add in this YAML, right? I'm specifying image pull secrets with the name that's going to reference my values file. That's it. That's all I need to do for deployment, because the next modification I made was ingress. So I'm going to go over to ingress, and you can see the ingress here is very simple. In fact, the only thing that's getting referenced in values is the service port. But I have annotations, I have host names, I have other things that I care about. So I'm going to delete all of this, and I'm actually going to paste in my own ingress. And you can see ingress enabled. Now I have annotations, I have host name, I have service port. It gives me a lot more power and is actually going to work. So I have my ingress upgraded, my deployment is working, my values file looks good, the host name looks good. So now we're ready to make sure that we can actually build this and then use Azure Pipelines for release. Again, the Dockerfile, we know that that works. It worked locally. Going to Azure Pipelines here, we have all our tasks. I always like to triple check everything, but this looks good. We are going to make sure on our git ignore that target is perfect. Target is excluded. So all I'm going to do is add in these changes, stage everything, and just say push for demo. Commit, push. So the second I push this, because Azure Pipelines is part of my repo now, GitHub and Azure Pipelines already have an agreement to start off any new builds. I don't have to enable a trigger, it just automatically exists. So we'll go to Google Chrome. I'm going to go over here to my pipelines, and under builds, I should see that push for demo automatically started. So I don't have to start it. I don't have to do anything. It's going to just act off of whatever I defined. In a way, Azure Pipelines works very similar to the declarative nature of Kubernetes, right? I state the way of the world I want it to be, and Kubernetes makes it so. In this instance, with Azure Pipelines builds, I state what I want Azure Pipelines to do, and Azure Pipelines does it. So it's really powerful. Once this builds, it's going to have to do the build, push. It'll package up my Helm chart. And assuming everything was written correctly, we'll be able to go through and release it off into my Kubernetes cluster in Azure. So I'll circle back when this is done. Okay, so now the job finished, everything was successful. I can even go over to summary, and I can see a summary of what was published. Here's the build artifacts that are ready to be used in a release. I can click the ellipses here, view contents, and I can actually see the artifacts. I see my tar file, which is my Helm chart actually zipped up and it's versioned. And then if I drop down Maven, I see my jar as well. So that's really nifty. Now I'm going to kill this and we'll go over to release. By the way, under deployments, if I did have CD already set up and a release were already in progress, you'd even see a release firing off right here as well. So it gives you a locality inventory of everything that's happening for your build, release, artifacts, and any changes. So I'll click release now, and that's going to take me over to the CD part of this deployment. But just like on our build, it's going to suggest a template. Do you want to start with something that's predefined and then make it your own? Or do you want to do an empty job and add your own tasks? I'm going to search for Helm and see that there is already a template for Helm charts with Kubernetes clusters. So I'm going to hit apply. I'm going to name this staging. Hit a G. Close this. Now I need to add in a few settings, particularly my Azure subscription. So I'm going to add in my available subscription because I've already authenticated it. But in the event that I hadn't, let's say that I wanted to add this one, all I would have to do is hit authorize, or I could hit the drop-down arrow, go to advanced options, and from here, I can actually create a service principal authentication and scope it down to a resource group. So I can give it as much or as little control as I want it to have. I have already enabled a service connection to my default subscription, so I'm going to leave that authentication, and now I'm going to choose the resource group for my cluster, and then I'm going to choose the cluster itself. So that's the hard part. The next step is actually the Helm upgrade command, and this is the same command that I would run locally if I were deploying it. The first thing I'm going to do is I'm going to deploy it out to the Jfrog namespace. This is also the namespace where my Docker secret for my image pull secrets exists. And I'm going to choose a chart path. And in case I don't know that path, I'm going to click the ellipses. We're going to go over here to linked artifacts. We're going to drop down. We're just going to find our WebSocket tar file. This is our chart that's going to tell Kubernetes how to handle the deployment. And now from here, I'm going to name it. We're going to name it Jfrog as well. I guess we could call it Jfrog chat. And then from here, I need to actually set some values. So the cool thing is when you do look, let's go to our Visual Studio Code, and you look at our values file. All of these, just because they are set into a tarball and versioned and packaged up at build time, does not mean they're set in stone. I can override them per environment at any time that I wish. So one of the things I still need to add in is I don't have anything for my image repository and my tag. And I intentionally didn't add that in the values because that might change. I might want to use Azure Container Registry. My build ID is definitely going to change because my tag is my build ID. So it's going to change each build, right? I don't want to just use latest. So if I go over to Google Chrome, luckily using this particular task, and again, it's just like a task runner, just like on build, I can add in my image repository, which is Jfrog JD, Springboot, and then the image tag is using a predefined environment variable. I can see that same information right over here on Springboot, and I can see any of the build IDs that were pushed. So as long as this name is the same as the other one, the deployment is going to work out well. But I'm not completely done yet because this is just really HelloWorld. So let's go back over to pipeline, and I'm going to clone this, and we're going to make production. Okay, and now I need to make a few changes. For one, I'm going to have an issue with the DNS with the FQDN, right? Because I can't have two website applications go to the same name. So I'm going to delete this and we will overwrite it with production. So I have the same image repository, build ID, but this time I'm going to override that ingress hostname with the same kind of name, but JFrog 19 prod. I'm also going to make sure I deploy this to JFrog prod, right? I'm going to put it into a different namespace. Namespaces are really powerful with Kubernetes because I can keep my applications and everything kind of isolated. So I want deployment to go to one namespace, another deployment to go to another. But we're still not done because I don't want my deployment to flow just from staging right over to production. I'm going to put in some post-deployment conditions and pre-deployment conditions. So the first thing I'm going to do is a post-deployment approval. And then I'm going to do the same thing on a pre-deployment approval. Now, that might not seem like a big deal in a two-environment setup, but if I were using something like staging, QA, canary, prod, especially when I get to QA, I might not want my deployment to automatically just be approved and go off to production. I might not be ready for it yet. So I want to make sure that as an approval, I choose that it gets approved, but it doesn't just automatically flow because somebody approved the post part of it. You can also use things like gates, which we'll talk about in a future demo. But for now, I'm just going to have pre and post deployment approvals. So we'll double check a few more things. I can see the continuous deployment trigger is already enabled. You can see the pre-deployment conditions on staging doesn't exist. Everything looks good. We'll double check our tasks one more time. You can see the agent job actually this time is using a hosted Windows server. It doesn't matter which hosted agent I use for the release because Helm is going to work on anything really. So all that we care about is making sure that our namespace, we'll triple check. That looks good. Our image looks good. We'll do the same thing where I can drop down and quickly change to my different environment right under tasks. Again, the agent job is the same here. Go to Helm upgrade, namespace is prod, release name is chat. And I can name it the same release name. It's just going to go, actually, you know what? I will change this to prod. That way we can be able to see that in our Helm list. And otherwise, everything looks good. So let's go back to pipeline. I'm going to hit save. And since I've already built it, I've already made my changes, it already has a packaged artifact, all I have to do is hit release. Once I hit this release once, any other changes I would do a git push and commit and all that too, the pipeline will already exist and it could flow through as I've configured. So let's go ahead and hit configure or create, and it's going to tell me release 1 has been created. So I can select this, and just like in build, I should be able to watch as this creates. Now I'm going to switch over to iTerm here, and I'm going to change to my actual Kubernetes cluster out in Azure. And you'll notice that I have a watch command on the left-hand side here. I have one watching Jfrog prod, and I have one watching the namespace Jfrog. So once staging actually starts running that Helm upgrade command, which is the third task, we should see that container ultimately create right here. So we'll get to watch it live. Let's go back over and bring this up in the background. So you'll see this initialized task. It's setting up, it's downloading our artifacts, which was created in the previous build. It's setting up our release server with Helm. Now in the future, you could set up your own private agent that would already have that. Now it's going to run the Helm upgrade command. So we'll let that run in the background, and as it does, you'll be able to see right here, it's pending, containers creating, and it looks like our deployment is already complete, and now it's up and running. But just like how we had to wait locally for the logs, we're going to have to do the same thing for our application to actually be up and running. So what I can do is we'll copy this, we'll do kubectl get pods -n Jfrog. Okay, that is the pod. Now we'll do kubectl logs and Jfrog. There. So you can see it's adding the welcome page. We watched all this locally, right? So we want to make sure it looks like the start of the WebSock application. So we already know where our ingress is, right? Because we defined it in our values file. But let's do one step further. Let's do kubectl get ingress -n Jfrog and hit enter. And you can see the ingress is right here. It's been up for 1 minute. So let's go ahead and copy this address, go back over to Chrome, paste this in. I might have to do this in a private browsing session. I was noticing that sometimes I get some caching, but it looks like it works. So let's go ahead and test it. I'm gonna do jldeen, start chatting. And then now let's start a private browsing session, and we'll have this go to the same address. And let's see, I'm gonna do Miley. That's the name of my dog. And so Miley says, woof, woof, send. And you can see in the background here, JLD joined, Miley joined. So the chat application works. That looks good. But let's test our Azure DevOps pipeline all the way through. I'm going to close this. I'm going to close this one. You can tell right now that if I take a look at our full release, it's pending approval. It hasn't gone on to production. So let's go ahead and approve. I'll do, looks good to me. Should say woof for Miley. That's approved. But right there, our pre-deployment condition for our production environment caught it and said, no, you're still not ready. I need another approval. So I'll go in and hit approve again, just for the sake of the demo. Good to go. And we'll hit approve. Now, just like in the previous stage, we'll be able to watch and see as it requests an agent and as it deploys. So while that is deploying, we'll wait for it to get to step 3, and we should be able to see that same deployment happen right up here in the Jfrog production environment. And we'll be able to go to the same application, just in a different domain or fully qualified domain name. And again, all that ingress and essentially host name information is available in one of my previous videos where I walk through how to set that up in 15 minutes, I believe, is the total. I think the entire video might be 17 minutes, but 2 minutes of it was when I was talking. So I'm going to flip back over to Azure DevOps. You can see right now this does happen sometimes because they're hosted agents. So it's still waiting for an available agent. Once it finds one, it'll go ahead and start the job. You can speed up certain parts of this process and certain bottlenecks by using your own agent. And personally, in certain situations, I do, especially when it comes down to big Docker files or big Maven builds. Sometimes pulling all those dependencies, especially if it has to pull and push, some of those build steps can take anywhere from 5 to 7 minutes. But let's flip, it just did that. So you can see, here we go, it's creating a container in prod. It's been running for 8 seconds. So we'll do the same thing here. Let's do kublogs and jfrog prod, and now we'll copy this address. This is the name of the pod, so we'll do that. There we go. And so you can see it's loading still Spring. We'll go ahead and also do kubget ingress prod. So we know that we have this host name, so that worked out well. We'll copy this over, and I'm going to do my logs command again so I can see where it's at. It's doing the welcome page. And there we go, it started the WebSocket application. So let's go over here, paste a new tab, paste in our production address. And you'll notice that both of the addresses, especially once this one loads, they are, I don't know if I've pointed this out, but they do have a valid certificate, let's encrypt. All of that is in the previous video. So that's how to go from literally nothing to a full deployment. Now, the next video will talk about better practices as far as how to actually control your dependencies, your binaries, use artifacts for Maven. We'll use Jfrog Artifactory in richer detail because right now we didn't even use it for our Helm charts, which would be best practice. But this is a very high level video of how to get started with basic framework. And then the next one will go a little bit deeper. Thank you so much for watching.